Welcome to Econ Minds, and let's move forward to solve example related to marginal utility. Our example number 10 is a numerical example of finding marginal utility for a perfect complement utility function. Suppose our utility function is a mean of 2x, 3y. And from the previous video that we derive the marginal utility formula for the perfect complement utility function, you know that a is equal to 2, which is the coefficient of x, and b is equal to 3, which is the coefficient of y. And we already covered that this utility function will take the format of ax if a is less than b, and will take the format of by if a is greater than or equal to b. So now, you know that a is 2 and b is 3. So it's clearly a is less than b. So then, this utility function uxy will take this format, which is ax, y. So, and a is equal to 2 here. It will change to 2x. Why? Because, let me write down here, because a, which is equal to 2, is less than b, which is equal to 3. So now, when this utility function will change to this format, so we can easily find out the marginal utility of x and the marginal utility of y. So then the marginal utility of x for this function, which is equal to x or 2x, it will be equal to 2. Just take the partial derivative or the derivative of this one with respect to x, and then the result will be 2. And if you find out the marginal utility of y, which is the partial derivative of y, uxy with respect to y, if you take the partial derivative of this function with respect to y, as you know that there is no y terms, so it will be equal to 0. It will be equal to 0. As we already covered, why the marginal utility will be equal to 0? Because here we do not have any y terms. So then the marginal utility of y will be equal to 0. So now let's change the shape of or the format of our utility function. Suppose this is 3 and this is 2. So now our b is equal to 2 and our a is equal to 3. So now, based on this explanation, our utility function will take this format, the format of by. The format of by, as b is less than a. b is 2 and a is 3. So now, our utility function will change to this format, which is u of x of y will be equal to, which is the mean is 2y, which will be equal to 2y. So now, let's find out the marginal utility of x and y for this type of utility function that we have now 2y. So in this case, as b is less than a, we'll take the format of by, which is b is equal to 2, it will change to 2y. So then, if we take the partial derivative of uxy with respect to x, which is equal to the marginal utility of x, as we don't have any x term here, so then the partial derivative of uxy with respect to x will be equal to 0. Then the marginal utility of x is equal to 0. If you find out the marginal utility of y, which is equal to the partial derivative of uxy with respect to y, and we know that the utility function is equal to 2y, if we take the partial derivative of this function with respect to y, it will be equal to 2. So now we clearly understand that the marginal utility of a mean value function or perfect complement will be the case that which one is in the mean value. If x has the mean value of this function, so then the marginal utility of x will be equal to the coefficients of x, and the marginal utility of y will be equal to 0. But if y is the mean value in this utility function, then the marginal utility of y will be equal to the coefficients of y, and the marginal utility of x will be equal to the coefficient, will be equal to 0. Will be equal to 0. So this is a numerical example about the marginal utility of a perfect complement utility function. I hope you enjoyed it. If you don't know how to find out the formula, I suggest you to watch the other video that I put down the link here related to how to find out the marginal utility for a perfect complement utility function. Hope you watch my other videos as well, and hope you don't forget to subscribe my YouTube channel and share these videos, and hit that like button in order to enjoy together. Thank you so much. See you next time.